Now, my dear children, now we will go for understanding lamps in series. Earlier I told about batteries in series. So, when two batteries are connected in series, the voltage got added. Suppose this is 1.5, this is 1.5. So, ultimately because we have connected them in series, so here it is 3.5. That's what you have seen, right? Good. But now, that 3 volt has come up to these bulbs. But here, this is one 3 volt bulb and this is another 3 volt bulb. So, we have connected two bulbs in series. So, that 3 volt is shared by this fellow and this fellow as well. That's why the voltage across this bulb is going to be 1.5. The voltage across this bulb is going to be 1.5. So, if we are giving only 1.5 volts for the 3 volt bulb, it will be offline. Let us check that. Let's check that. Right? So, let's check that. Now, let me see what is the voltage of the battery right now. Yeah, 3 volts. Okay. Now you can switch on. Okay. Now, I am going to see the voltage across the lamp 1. Yeah, 1.25 in assumed 1.3 because when current is pulled, the 3 volt is dropped down to 2.7 no. So each one is shared 2.7 divided by 2. So these two fellows are equally shared, you see. This is 1.2. Yeah, this is more drop. That means they are not equal. Okay, that means they are not equally made. There is some slight difference in between. That's why one is dropping 1.5 volts, the other is drawing more current and it is dropping 1.2, it is drawing more current. So current through this bulb and equal to current through this bulb also. Voltage across this one is a little lesser than this one, that's why it is little more bright. Okay, but anyway, what I wanted to tell you, though the current in the entire loop is the same, now, what I wanted to show you, if I short these two, suppose I have a wire, a piece of wire. So, I am going to short one bulb. What happens? Anyone can tell? So, I have a connecting cable wire. Okay, I am using one wire. With this wire, I am going to short one bulb. You see, one bulb I am shorting. So, when I am shorting this bulb, the current is not going through this lamp. The current is passing through this wire with no resistance. Through this bulb there is a resistance. So, all the voltage of the battery is directly applied. Okay. Suppose if I am shorting that side and this side will be.
If we short two bulbs,
then that is a total short circuit. Suppose if I short that one, suppose hold it. If there is no resistance in the circuit at all, suppose say if I short this one also, here, it is nothing but short circuiting positive and negative here. The switch will go on, our battery will be heated up and something can go wrong. Because short circuit. If it is shorted here also, it will be short circuited like you see. So we shouldn't short like that. At least some resistance must be there in the circuit. Some load must be there for the circuit. So we cannot directly short circuit the energy source plus and minus directly. Okay, you got it? Is it clear?
yes sir.
So the two lamps are sharing the voltage of that source. That's why the both are equally dim. When I am short circuiting one load, I am bypassing one load, automatically the other one is getting full voltage of the battery. That's why the other one is fully bright. That means as if earlier we have shown the circuit like this. We have shown with one bulb only we have shown We have shown the one bulb like. So in the two bulbs in series, I used to short one load, one bulb. So that used to be like this. Is it clear for you?
Sir.
Now you understood this one also. Now I wanted to, instead of connecting bulb, I want to connect a fan. Because I am feeling sweat. So I am connecting one fan. There is a motor here. Okay, there is a motor. Now this motor, you see, it's running. Now you wanted to see whether it's running or not. Yeah, you want to see the motor whether it's running or not? Come on. You want to see?
Yes, sir.
You see now what happens?
It's working.
Yeah? When it can fly like this, if I rotate it a little more speed, it can jump up. So I need a good batteries. Better batteries than these fellows.
There.
Okay, then let's see. We'll change the compartment. Ready? Push it.
Can I on?
Oh, yeah.
3, 2, 1, go.
It's not flying. Oi.
Oh my God. It flying for a second.
Let me see. No, it has to fly. Actually, the required speed is not coming up. That's why. We can do the other way. We'll change the direction. Oh, I got it. Why it is not flying? I understood. What is the problem? You know, I made it reverse, so now it has to fly. Oh, that is why it is not flying. Now it will fly.
Can I on, sir? 3, 2,
Yeah.
go. Wow.
You got it? Again you say. Now we'll change that battery, okay? Why this battery? We'll see that battery. So this is how we need to figure out the problem. Why it is not flying earlier? How your mentor found the problem? And how you immediately understood what is the issue? Happy?
Yes, sir.
Actually, I need not to lift actually if the battery is good enough, I don't have to do this lift also.
Wow.
If the battery is good enough, if I keep it on, after 1 minute it creates the required thrust and it will lift on its own. Understand?
Yes, sir.
Happy?
Yes, sir.
One photo. Now, my dear students, now we have connected 2 lamps in series and we want to measure the current. You see, it is 130 milliamperes. The both are glowing, but the voltage is divided by both the bulbs. That's why none of them is bright. Both of them are off the way. So, they are shade. The voltage is shared across the 2 bulbs. The 3 volt is divided by the 2 bulbs. So, some voltage is dropped here, some voltage is dropped here. So, the voltage drop across this bulb and voltage drop across this bulb is going to be the total voltage. So, I wanted to show you that also. See, now I am going to show you this. You see, the voltage drop across the first bulb. So I am going to measure in voltage, DC voltage, and you see. So now what is the voltage of the battery? The voltage of the battery is 2.7. Now I want to make sure the voltage drop of this particular bulb 1.2 and it's supposed to be 1.5. Yeah. So 1.2 plus 1.5 is nothing but a total voltage of 2.7. So total voltage is sum of the voltage drop across this bulb plus this bulb because they are in series. But it is not the case in parallel. I am going to show you the parallel connection also for you guys. But in this case, suppose say any link anywhere in the circuit, if something goes wrong, everything is stopped. Suppose say even this bulb is not working, and suppose say suppose I'll be connecting like this to show you. You see, I'm just connecting it like this. You see, my dear friends, see, if this bulb is on, this bulb is on in the series. If any one of the bulb is bad and the other bulb is also not glowing. So, though the physically it appears, but if say inside the filament goes bad, or one LED in the series LEDs for your festivals, you all use no serial bulbs, serial LEDs. If any one LED is gone in the entire serial connected LEDs, one gone and the rest of all the LEDs will be off. That is a drawback of the series connection. But the advantage is, if you have 230 volts AC at home, and then you have, so you can use a number of LEDs connected in series, and all together they can be directly hooked to the 230 volts AC. So that high voltage AC can be converted to DC, and that converted 230 volt DC can be converted to the series connected LEDs, maybe 100. That's where you are going to enjoy a different colorful LEDs used in serial connections. But only the drawback is, if any one of the LED in the entire serial connected LED array, all the rest of them will be off. That is the drawback. But it is not the case in parallel. That also we will verify and see. Okay. Now we will go for a parallel connection. The parallel connection is something like this. Suppose say I have a switch here, and then I have two bulbs here. Number 3. See, now I am connecting. See, the battery pass to the switch to this bulb and this bulb. Okay, I don't care plus minus here because they are the filament bulbs. And one more, 1, 2, 3, 4, 5, 6. So all the negatives are connected. So the negative of the battery is connecting to all the bulbs. Positive of the battery, through a switch it is connecting all the bulbs. So bulbs connecting parallel. That means the positive of this bulb connected to positive of the battery. Negative of the bulb connected to the negative of the battery. Now in this case, the most interesting thing is, even if you can switch on, you say both are, this is not glowing because this fellow is drawing more current. So you are not able to see the lamp here because this is drawing more power, more current, less resistance. So the current not entering in, going there, but it's not lighting the bulb. So we can do another way like this LED. We will connect LED and so on. Come, for LED we need a resistance. Okay, so we need to show you that also. Okay, let me see this way. First, let me see this way. See, this is coming. The bulb is working, but because of that is drawing more current, this is going back down. Okay, now we'll go for LED one. Then they can understand better. Give me LED one. No. LED. We need resistance between this 100 ohms. 100 ohms resistance, because for LED we can, without resistance we cannot use. One single. You see, 1, 2. So the battery is going like this, and to resistance it is going, and for the bulb it is going. Now 1, 2, 3, 4, 5, 6, 7. You see? Okay. Now you can see, my dear friends, when the switch is on, this one is also on, this one is also on. Suppose even if this goes wrong, this will still continue, or if this goes wrong, it still continue. That is the parallel connection. You wanted to make sure that? Now you can see. You see? You see? I have removed you see, my dear friends, I removed the resistance. I mean, this bulb is gone, but still it is working. Otherwise, if I keep it connected and if I make it open, and that will still continue. So in the parallel connection, they don't care. They equally work. If one is not working, other will continue. But in series connection, it's not like that. That is one important point you have to understand. But in the parallel connection, the entire current pulled by these two bulbs are equal to the current flowing through the bulb 1 and plus current flowing to the bulb 2. These two currents are, that means I1 plus I2 is equal to I. I is current coming from the battery. I1 is current going into the lamp 1. I2 is the current going to lamp 2. So I1 plus I2 is equal to I in the parallel. But in series, no. I is equal to, I1 is equal to I2. That means entire loop the same current. But in the parallel, no, it is not like that. This path can take more current, that path can take less current, or this fellow is take more current, or that fellow will. But ultimately the sum of all the paths is equal to the current supplied by the battery. That is what you need to understand. Okay? Is it clear? Good. We enjoyed a lot many things. Working with snap circuits. You can build many projects going through this book. Every page they have asked you connect all that and test them. They have given all the parts in the snap circuits kit box, and you can refer all this different projects and increase your knowledge by reading this and connecting them and understanding them one by one. But now today I have shown you the basics. So thank you all.